So once again, very good day to everybody. This is image analysis and recognition, and in today's class we'll discuss about the main heuristic features of images, histograms, texts, LBP, local binary pattern features, and then about the image search methods by the structure. So this is especially for you, my dear students and young researchers, and you can reach me at dr.christoananth@gmail.com. So before beginning the session, once again let me thank God for giving me this opportunity to deliver this useful session to share my knowledge among my fellow national, international participants, students and young researchers. So in this class we will discuss about the histogram of an image, why we use a histogram, and we produce a image matrix. Then we find a probability function. We find a histogram graph for each pixel and the corresponding occurrence probability. Then we try to display the histogram of an image without using a MATLAB library function. Okay. Then we try to create LBP, local binary pattern, okay, of an image using OpenCV Python, and about local binary pattern, the binary pattern, and of course the resultant matrix that we will be discussing. So I have already given the independent work for you. Please complete them at your best available time. I will be checking them. And at regular intervals, I will be giving you some short videos to discuss the knowledge in our topics. Right. So whenever you say histogram, you should remember this function. Okay. Right. So it is having the limit 0 to L minus 1. Okay. We have a discrete function. So the function we call it as a histogram function. It is h of rk equal to nk. Okay. So here it provides a global description or maybe the appearance of the entire image. Okay. Here the information which is obtained from the histogram is nothing but very large in quality. Okay. So it is nothing but the relative frequency of occurrence of gray levels. So that is the reason n is nothing but number and r is nothing but rate. So h of rk is equal to nk. Okay. So let us assume an image matrix. Okay, so this is an image matrix 3, 6, 6, 8, 5, 3, 1, 4, 8, 6, 5, 1, 4, 8, 2, 3. Okay, so this is an image matrix. As I told you, rows, columns, I, J. Okay, so the image matrix contains the pixel values at I, J position in the given x, y plane, which is nothing but two-dimensional. Why you call two-dimensional? Rows and columns. Okay. So there are two ways to plot the histogram of an image. So maybe you can have x axis which has gray levels or maybe intensity values, and maybe y axis has number of pixels in each gray level. Okay. So the histogram value representation of this would be this one. So you represent it as a graph. Corresponding to this matrix, you have to draw the histogram. Okay. So here we will have histogram versus intensity value. So corresponding to the value 2, 1, 3, 2, 2, 3, 3. So accordingly, okay, we draw the graph. So this is the histogram value representation of the above image. Okay. So you will have the above image like 1, 2, 3, 4, 5, 6, 8. Okay. So they are nothing but the intensity values, and the occurrence frequency of each intensity value in the image matrix you can have 2, 1, 3, 2, 2, 3, 3. We had the matrix. Okay. So that is according to the intensity value and occurrence of the corresponding intensity. So this one, the histogram and the intensity value, we map it accordingly with a graph. Okay. Right. So next you will have x-axis which represents the gray level. Okay. Y-axis is nothing but probability of occurrence of each gray level. So the probability function P of rk equal to n. N is nothing but number. Okay. N. K number. Okay. Nk divided by n. Okay. So remember this function P of rk is equal to nk divided by n. Okay. So maybe you can assume like a intensity value or gray level 1, 2, 3, 4, 5, 6, 8, and similarly occurrence of the intensity value number of pixels 2, 1, 3, 2, 2, 3, 3. So this one is actually got from this one 2, 1, 3, 2, 2, 3, 3. Ikta bir, uch, ikta, uch. This one here. Okay, and we calculate the probability of rk is equal to nk divided by n. We are calculating the probability. So that is the reason 0.125, 0.0625. We are calculating the probability. Okay, right. And we calculate the histogram graph for each of the pixel and the corresponding occurrence probability. So here we got 0.125, 0.0625, 0.1875. Everything we are doing. Histogram probability versus intensity value 0.125, 0.0625, 0.1875. So everything we are marking it as a graph. Okay. Right. So the image histogram is nothing but a chart representation of the distribution of intensities in an indexed image or maybe a grayscale image, and it will be showing how many times the intensity value in the image is actually occurring. Okay. So then we have a code. Okay, you are going to display the histogram of an image using the MATLAB library function. Okay. So maybe first of all you have to read the image in the MATLAB environment. So img image is equal to image read, okay, im read apple.jpg. So you are going to access the image called as apple, okay, and you have to convert this image to the grayscale image. So if the read image is a RGB image, then you will have image is equal to RGB to gray of image, okay, and you have to show the histogram of the image. You have to plot, okay. So using the im histogram function, you are going to have, so im histogram of image, okay, and you are going to display the histogram of the image using MATLAB library. So that's another example, okay. So you have to read the source image file into the image matrix, then you have to convert the grayscale. If maybe if it is a RGB image, from the RGB you are going to convert to the grayscale, okay. So you will have this one, okay, read source image file img image read apple.jpg, then you have to convert from RGB to grayscale, okay. So image equal to RGB to gray of image, then you have to get the dimension, what is the size, okay. So xy is equal to size of the image, then you create a frequency array of size 256, that is the total limit, okay. So frequency is equal to 1:256, okay, then count equal to 0, then you try to iterate increment, okay, over the grayscale image matrix for every possible intensity value, and you try to count them, okay. So for I equal to 1 to 256, for j equal to 1 to x, and for k equal to 1 to y, you go for this condition. So if this image of j comma k is equal to the condition I minus 1, then you go with the count is equal to count plus 1, then you go with the end statement, okay. So end all this one, and then you try to update the ith position of the frequency array with the exact count. So frequency of I is equal to count, and you try to reset the count to 0. So count is equal to 0, then end. So our actual limit is from 0 to 255, okay. So n is equal to 0 to 255, and you display the histogram. So stem n comma frequency grid on y label, it is nothing but the number of pixels with such intensity levels, and x level is nothing but the intensity level, okay. So this you will have the title to be histogram of the image, okay. So this is the output. So for example, this was the input image that was given, and correspondingly output you see histogram of the image, okay. Here you find number of pixels with such intensity values on the y-axis, intensity levels on the x-axis. Corresponding to this, the intensity levels are categorized. This is the histogram of the image. So you know, whenever you say image, you are taking photo in your mobile camera, it is nothing but pixels, okay, a group of pixels. So when you store this image in computers, definitely its corresponding pixels is actually stored. So maybe when we read an image to a variable using OpenCV platform, okay, the variables will be storing the pixel values of the particular image, okay. So maybe in the Python you will have import cv2, okay, cv platform, image equal to cv2.imread, image read gfg.jpg, or maybe apple.jpg you can have, okay. So now the variable image will be storing the pixel values of that particular image. Maybe you'll go with print of image, okay. Then for example, let us take in the case image processing for bachelor and master students. Let us take in the case, this is the example. So correspondingly its pixel values are stored 255, 255, 255, okay. You will store different numbers, okay, corresponding to that particular image corresponding to the x-axis, corresponding to the y-axis will be having. So similarly, we try to generate LBP, local binary pattern. So here we will be having texture descriptors. You are going to extract the information out of the image. So for this one, we will use local binary pattern. It is nothing but a grayscale invariant texture descriptor for classifying the image. Okay. So in local binary pattern, binary means what is that? Bir null. Only ones and zeros. Okay. So binary code is actually generated for each of the pixel value by thresholding. Okay. So you are going to fix the threshold limit and you will be having the neighborhood pixels to be maybe 0 or maybe 1 based on the value of the center pixel. Okay. So the rule for finding is that you have to set the pixel value as the center pixel and you have to collect its neighboring pixels. Okay. So maybe if you take like 3 cross 3 matrix, the total number of neighborhood pixel is actually 8. Okay. So maybe 3 cross 3 means 1, 2, 3, 4, 5, 6, 7, 8, 9. Tokus. Center pixel you take. What is that? Secus. Okay. So that is the reason total number of neighborhood pixel is 8. Okay. So threshold, its neighborhood pixel value to 1 if its value is greater than or equal to the center pixel, otherwise null. So after thresholding, collect all the threshold values from the neighborhood either clockwise or maybe anti-clockwise. Okay, so the collection will be giving you an 8-digit binary code. Convert the binary code to the decimal and replace the center pixel with the resultant decimal and do the same process for all the pixel values. Okay, so maybe we will try to understand. Okay, so we are taking a value 149. Okay, and it's corresponding 8 neighborhood pixels to form a 3 cross 3 matrix. Okay, for example, 255, 253, 220, 220, 118, 128, 113, 118. Here you find like this. Okay, this is the center value 149, 149. This one 1111. This one 0000. Okay, so this is after thresholding. This is after thresholding. Okay, so collect the thresholding values. What you had? 11110000. Yes, so we collected the values. Okay, so collect the thresholding values either clockwise, clock, clockwise or anti-clockwise. Okay, or anti-clockwise. Okay, so we are collecting from clockwise from top to left. Okay, 11110001. Okay, right. So convert the binary code into decimal and place it at the center of the matrix. Okay, 1, say 1 1 1 0 0 0 0 1. This is to the base 2. Okay, this one you have to convert it to base 10. How will you convert? 1. You know what is that? How? Tell me. 1. So 1 multiplied by 2 power 7. 128. Bir use igrama sakas. Bir use igrama sakas. Okay. Wait. Plus this one. 1 multiplied by 2 power 6. Plus, listen, 1 multiplied by 2 power 5 plus 0 multiplied by 2 power 4 plus 0 multiplied by 2 power 3 plus 0 multiplied by 2 power 2 plus 0 multiplied by 2 power 1 plus 1 multiplied by 2 power 0. Correct? 1 multiplied by 2 power 0. Now you tell me what is the answer. Ike use tokus. 128, this one. What is this one? What is this one? 64. Uttu Sikta. Ike use. Wait. 0, 0, 0 plus 1 multiplied by 2 power 0. What is the value? So after converting to the decimal, the center part you are going to change. This is 225. Earlier you saw 149. This one you change 225. That's all. This is the matrix. Okay, right. So this is the Python code. Import CV2, import numpy as the numpy model. Okay, so from matplotlib, import the pyplot as the plt. Define the get pixel, image, center, x and y. So the new value equal to 0. Okay, and you'll try if the image of x and y is greater than or equal to center, then the new value equal to 1, and except you go with the pass value, you return the new value. Okay, so here exception is actually required when the neighborhood value of the center, okay, is actually null. Okay, so that is the reason you go with the pass and then return new value. Then for finding the LBP, local binary pattern, you define LBP, calculated pixel, image comma x comma y. So here we are calculating igrama use, Ika use igrama bish. Okay, so that we have calculated for as the center pixel. So center is equal to image xy. Okay, so value AR array equal to null. Okay, top left the value array append get pixel image center x minus 1 y minus 1, then top right, bottom left. So this is what for everything you are categorizing: x minus 1 y minus 1, x minus 1 y, x minus 1 y plus 1. That is actually right. Okay, then right x comma y plus 1, and similarly bottom right x plus 1 y plus 1. Okay, bottom x plus 1 y, bottom left x plus 1 y minus 1. Okay, and left x comma y minus 1. So for each of the things we will have. Then we have to convert the binary values to the decimal. Okay, so the power value you will have 1, 2, 4, 8, 16, 32, 64, 128, and you specify value equal to 0. For I in the range, you calculate the length of the value of array. So value equal to value plus value of array of I, which is nothing but the power value of I, and return the value. And similarly, the path you are going to have like apple.jpg, and image bgr equal to cv2 imread, the path comma 1, height width you are going to have the background shape. Okay, so the image gray you are going to convert. Okay, so cv2.cvt color image bgr. Okay, and then cv2.color bgr to gray format we are going to convert. Okay, then create the numpy array as the same height and width of the RGB image. So image LBP, local binary pattern, numpy.zeros, height, width, and numpy.unit8. Okay, and you'll have for I in the range 0 comma height, then the j loop for j in the range 0 comma width, and image local binary pattern of I comma j, that is nothing but the calculated pixel what you have now found. Okay, so it is image array I comma j. So you will have plt.imshow image bgr, plt.imshow the image lbp. So the C map is nothing but the converted gray image. Okay, and plt.show. Okay, and print lbp program is finished. Okay, so you will have image processing for bachelor and master students. It will be converting grayscale image. It will be converting. So image processing for bachelor and magistratura talabla you will be having. Okay, so this is the output. Will be having the values in the x as well as y axis. So that is nothing but the width as well as the height of the input image. Enable and work BISH. Demonstrate with the help of the programming code how you try to build a image search engine like Google image search engine using Python.